Now you're looking at at this example, you look at the line with the vector form like this. You look at the line like this, and you look at the plane this time. So you now look at the line and the plane is like this. They use another two Greek letters here. Normally, when we introduce planes, we use lambda and mu, but this time they use another two to separate them from this lambda. So they need three different parameters. And the question is find intersection, if any, of L and P. L is a line, P is a plane. Find intersection, if any, of L and P. Again, with the row echelon form help, look, again, everything can be done with the row echelon form without even actually producing the numerical solution. All we have to do, we have to write proper vector equation and then have to fill the augmented matrix with the right vectors as columns. So the test for intersection, your line is, if I introduce the abbreviations as before, if I call this normally, like normally we call with vectors, this will be vector A, this will be vector B, this will be vector C, D, and you'll be surprised, F. So in vector form, you're looking at the line with this equation, A plus lambda B, and you're looking at the plane with this equation, vector A plus lambda B, and here C alpha D plus beta F. So the test for your intersection is this test. So again, first step, the problem starts with our interpretation of the geometric condition intersecting in terms of algebraic things which we are looking at. And this test of intersection in algebraic terms, it means that this right-hand side must be equal to this right-hand side. One right-hand side must be equal to the other right-hand side with some choice of the parameters lambda, alpha, and beta. So the test for the intersection now look like this. The right-hand side of the line equation must be equal to the right-hand side of the plane equation. If you rearrange this the way you normally rearrange things when you look at the system of linear equations, but not ruining the fact that actually we're dealing with the vector equation, so you keep it in vector form. If you rearrange it, like bringing all unknowns on one side, bringing all knowns on the other side, you will look at the vector equation like this. Right? So all of the unknown components like alpha and beta, I took them here. And all of the known parts, they went on the right-hand side. And now you look at the proper vector equation. You don't have to expand it into the per component form because all of that is a sort of a routine we can skip now. All you have to do, you have to fill in the augmented matrix with the right columns and do your row echelon form on that. So the augmented matrix will have how many columns on the left-hand side? 3 columns, and 1 column will be on the right-hand side. You have to do a bit of the arithmetic on this one, but it's elementary one. So here's my augmented matrix. Here it is. I just follow the recipe. The steps which I just described for you. That's the components of the B vector. These are the components of not D, but negative of D vector, negative 3, negative 5, negative 1. And these are the components of negative of F vector. C take A, well, C take A, it's a bit of the arithmetic here involved. C take A, that's a C, that's A. I don't think I made any mistakes. Negative 1 take 3, negative. The other way around. Sorry, yes, A, which is this. I was scared I made a mistake. C take A, yes, negative 1 take 1, negative 2, negative 11 take negative 13, negative 7 plus 1, it's negative 6. Again, you can go to the row echelon form. I have a solution. This one is in the solution helper. It's problem 8 there. All the steps they explained. If you have any troubles with that, they will be there. The row echelon form. Where is it? I wonder. Here we go. It's here. The actual row echelon form is like so. Yeah, we took the last row here, we put it in the first position, and then we did the elimination, and then more elimination. Yeah, that's the row echelon form of that. Already by looking at this row echelon form, you can tell me the answer to the geometric question. We have intersection or we do not have intersection. The answer will be we do have the intersection because every column, because the right-hand side is not the leading column. In fact, we have only one intersection, which means that the line actually punching through the plane, rather than being like entirely on the plane. For instance, if as a result of these manipulations you had non-leading columns on the left-hand side, meaning that you have multiple solutions, these multiple solutions, you would interpret these multiple solutions in your geometric context as if your line entirely lying on your plane. Whereas the single solution interpretation for that is just line punches through one single point, because it's a single solution case. Are you with me? Now, with this question, of course, you can take it a bit further by asking what exactly the point of intersection, and for that you need to solve for your parameters, lambda, alpha, or beta. If the question, actually the question itself doesn't really, actually it does, find the intersection, it says. Yeah. So we need to find actually the point of intersection, and for that we need to find the values for the parameters. Not all of them, in fact, just one of them will do. Just by knowing the lambda, which corresponds to this intersection, will be enough, because putting this lambda in the equation of the plane will give us the point of intersection. I think this time I did it like I didn't do, you could do back substitution here, but because I have a solution helper, and in that solution helper, actually this matrix is taken further to the reduced row echelon form, so I benefit from that. So if I take it further on to reduced row echelon form, we normally abbreviate the reduced row echelon. That's how we normally abbreviate the reduced row echelon form. The result of that will be this. That's there in this problem. These steps which are concealed by dots, they're in this one. Now, here's your parameter lambda. Here's the column which corresponds to alpha. Here's the column which corresponds to beta. And you can see that your alpha is 2. You also know beta. You also know alpha. Sorry, I said alpha. I meant lambda. From the first line, you see that lambda is 2. From the second one, alpha is 3. Beta is 1. I think I have it somewhere. I have it here. Yes. Lambda is 2. Alpha is 3. Beta is 1. Negative 1. Again, like I said, you don't need all of them to find the point of intersection. Just one of them will do. If you are in a time-stressed environment, you can do some shortcuts after lambda only, but shortcuts will go from here, of course, from the back substitution with the non-reduced row echelon form. So if you put this into the intersection point, will be, if I take this lambda equal 2 and I put it into my line equation, 2 will be here. If you do the arithmetic, it should be the point 761. Let's just double check. If lambda is 2, 1 plus 2, 3, 6, 7, 2 plus 4, 6, and negative 1 plus 2, yes, the 1. That's the correct one. This is a point of intersection.